Hello guys, welcome to Inside Electronics. So in today's episode I'm going to show you how do I measure the capacity of my 18650 lithium ion cells. So there are actually a lot of methods, there are a lot of scientific methods available to test your battery capacity, but I'm not going to explain about that here. What I'm going to do here is to show you guys my way of determining the capacity of these cells. Now, before the beginning, I have to admit that this is not a fully scientific method, but it gives out a capacity, roughly the nearest capacity that you can get with your scientific calculations as well. So for this experiment, for this purpose, all you need is a standard battery power bank or any lithium ion chargers like the TP4056 board that you can buy off eBay, and you definitely need one of these. Without this you cannot do it. This is the uh, USB charger doctor, but an advanced version of that. You can watch the full review about this by clicking the I button right here. And you need a standard USB charger. Now the thing is, the first thing you need to do, or the first thing I do, is to discharge these cells to their lowest possible voltage, and in this power bank it is 3.2 volts. So I'm going to I will be discharging these batteries down to that voltage. And for discharging, there is USB loads, those cheap resistive USB loads available on eBay itself. You can buy that. It doesn't even cost you $1. If you buy from websites like those Chinese websites, you can get it for literally 50 cents or something. And to discharge these cells, this is what I use. It may look ugly, and at the first look it may not make any sense, but it's okay, because this is all it is. It's just a USB cable whose wires attached to a couple of transformers, the secondary of two transformers. Let me show you this in detail. See, the two wires that are coming from the USB cable are these two wires, and they are connected in parallel with the secondary of these transformers. Now that is because it offers the secondary usually is a lower resistance and it draws a lot of current, and with this arrangement it draws around 850 to 900 milliamps. That is fine, because that is fine for discharging it, but the only thing is it will be much slower because the lower discharge current. Now this right here, this could alone be used as a discharging device, but the problem is that these incandescent bulbs, even when connected, three of them in parallel, will draw only around 350 milliamps, 350 to 400 milliamps maximum. So what I just connect these in parallel. And the reason why I connect this in parallel is not because it will draw additional current. It is because to prevent a backfire thing, which I will be explaining to you later. So okay, I will explain it right now itself. These kind of power banks actually use switching conversion to boost the voltage, the 3.7 volt to 5 volt output. So what happens is that if you connect the output directly to an inductive load like this transformer, and also when these transformers do not have any diodes across it, so what happens is that when the battery dies out or the power bank turns off, usually the last LED will blink and then the whole thing turns off. But in the case of this one, when it is connected to this transformer alone, what is happening is that the last LED, when it turns off completely, even after turning off completely, this last LED just keeps on blinking really fine, in a really fine level. It keeps on blinking like that. So I don't know what is happening. Maybe it's because the inductive load is reacting back to the switching action of this board itself, so that is causing that LED to actually light up. So to prevent that happening, all I did is just add a resistive load in parallel, and that solved the problem. When the resistive load is attached in parallel, the device is actually working pretty fine, no problem at all. So let's keep that to the side. And it has a USB port. So the first thing I do is discharge the cell. It's pretty simple. All I do is attach it and connect it to the power meter and then attach the load. So right now it's drawing around 820 milliamps, and as you can see it has 3 LEDs right now turned on, and gradually it will all turn off. And just this meter, I have attached this meter just to get a rough idea about how much current has been taken out, just for that. And once, let's say this thing has completed discharging, I will be using a fully discharged cell, which is this one right here. So this is a fully discharged cell. I'm connecting it to the circuit. So once it is fully discharged, what I can do is do the opposite of what this is. So once, say let's say this is fully discharged, so all I do is I connect it to a standard USB power bank. I reset the meter to 0 by press and holding this button right there. I can reset it. Now once I make sure that that is 0, I will charge it using a standard USB cable arrangement like that. So once that is charging, you can actually see how much power this thing draws. So since the battery is fully discharged, the value that you get from here will be the capacity of the cell, because that is how much amount that is being taken into the cell. But do not stop it just one time. You have to charge and discharge these cells multiple times, like say 3 times, and you have to fully charge the cell for 3 times and discharge the cells 3 times. Each time you have to take a note on how much charge has been taken into it and also how much charge taken out from it, if you want to calculate the efficiency. Otherwise you only need to calculate the charge that has taken into it. So after 3 charge and discharge cycles, just average out the total amount of charge that has taken into the cell, and that will be your cell capacity. Now this is the method that I use to calculate how much charge my cells can take. And as I mentioned, this is not a fully standard method, fully scientific method, or even a standard method, but this is how I do make it happen, and it works for me. The other good reason for using this is because by attaching the tester when the cell is being discharged, I can actually get an idea about how fast the cells discharge. Because sometimes when these cells get really bad, even though they can take a hell lot of charge into them, they cannot give out all those charge. For example, I have a faulty cell over here. This is a faulty cell. This thing can take around 1000 milliamps in, but it can only give out like say 400 or 500 milliamps from it. So by that way I can actually identify if the cell has any issues also by attaching the tester to the output and taking a reading of that also. So I hope you understood the method to do it. If you want to try it out, you can try it out, because it works for me, but I cannot guarantee it works for you. But anyways, thanks for watching. See you in another video.